Hi guys, so we are going to look at the empirical formula. How do you calculate it from the given grams of the components? Okay, so this is a very general roadmap that we're going to follow. First, we're going to take the grams of each of the components and convert them to moles. Next, we're going to look at the mole to mole ratio. We're going to take the lowest moles and we're going to divide that by the moles of each of the components. Now, in order to get the moles with a whole number, we need to either round up or round down if it is needed, or we need to multiply it to get the lowest whole number ratio. So once we had the lowest whole number ratios, we are going to then write it in the empirical formula. So really there are like 3 steps or maybe just 2 steps to do this problem. So let's look at this. We are given potassium, hydrogen, oxygen, and phosphorus. Now, we are given the grams, okay, of potassium, hydrogen, phosphorus, and oxygen, as you can see on the screen. So the first step is to find the moles. So each of these are going to be first converted to moles. So we are going to look for the molar mass of potassium in the periodic table, molar mass of hydrogen in the periodic table. By molar mass in the periodic table, I mean to say the mass number of each, or the atomic weight, as it's also said. Okay, so phosphorus, 1 mole of phosphorus, okay, and same 1 mole of oxygen. So we see that potassium is 39. Now write down the numbers exactly that you see in the periodic table. So it's 39.0983 grams. So this is known. Then hydrogen is 1.00794 grams. And phosphorus is 30.9738 grams, and oxygen is 15.9994 grams. Okay, so when you take 28.7 divided by 39.0938, obviously 28.7 multiplied by 1 divided by 39.0983, we are going to get 0.7340 moles. And these are the moles of potassium. Okay, next for hydrogen, we have 1.5 times 1 divided by 1.00794 grams, and that comes out to be 1.4882 moles of hydrogen. For phosphorus, we are going to take 22.8 grams and times 1 divided by 30.9738 grams, and that gives you 0.7361, sorry, 0.7361 moles of phosphorus. Next is for the oxygen. Similarly, 47.0 times 1 divided by 15.9994 grams, and that gives you 2.9376 moles of oxygen. Okay, so the next step is the mole to mole ratio, and for that we are going to do this is the step 1, and the second step is mole to mole ratio. Okay, so first of all we're going to see the lowest moles. The lowest moles are point of potassium, 0.7340. so that's the lowest, sorry, those are the lowest moles. So we get now potassium 0.7340 divided by 0.7340, and this gives you 1.00 moles. That's the potassium. Hydrogen is 1.4882 divided by 0.7340, and that gives you 2.03. Then moles of phosphorus. Phosphorus is 0.7361 divided by 0.7340, and that gives you 1.00. Oxygen is 2.9376. That's the oxygen. Sorry, I need more space. So oxygen is 2.9376 divided by 0.7340, and that gives you 4.00. So these are the ratios of each of the elements, the moles of each of the elements. So now we are going to put them in the empirical formula, the last one, and that is the third. Empirical formula is potassium, hydrogen, just write this down first, phosphorus, and oxygen. So potassium is 1, hydrogen is 2, phosphorus is 1, and oxygen is 4. So KH2PO4. That's the way to write. Okay, so it's okay to leave 1. So this is one example in which you are taking off when the grams are given to you. On the other hand, if you are given the moles in a percentage, then if you're given the compound, the components in a percentage, then what do you do? So let us look at another example here, which is in which you are given let's say phosphorus, and you are given 46. So here's the thing. So this is your second problem. And in this second problem, you are given phosphorus, and that phosphorus is a certain percentage, and that percentage is 43.6%. 43.6%. And you are given oxygen, and that oxygen is 56.4%. And you need to find the empirical formula. So in this case, you're going to consider this to be sample is of 100 grams. And that sample of 100 grams contains phosphorus 43.6%, means that is equivalent to 43.6 grams of phosphorus. And this 100-gram sample contains 56.4% oxygen, and that is equivalent to 56.4 grams of oxygen. All right. Okay. Now we're going to do the next thing is once we have these grams, we are going to convert them to moles. So we start writing. You take the grams, convert to moles. So we have phosphorus, which is 43.6 grams times 1 mole of phosphorus over the formula mass of phosphorus, which from the periodic table, which the molar mass or the molecular weight or the mass number of phosphorus is 30.97376 grams. So, pretty much you can round it up to 31, but it's sometimes, just copy the numbers as they are. Then this gives you 43.6 multiplied by 1 divided by 30.97376, and that gives you 1.4076 moles of phosphorus. Okay. All right. Then you have oxygen. Oxygen is 56.4%. 4 grams. That is coming from the percentage, right? And that is going to give you 1 mole of oxygen is 15.9994 grams. Again, this is the mass number of oxygen. So 56.4 times 1 divided by 15.9994 grams gives you 3.525 moles of oxygen. Okay, so now we have these 2 moles with all these decimal points. What do we do? So that was your step 1. Now let's look at step 2. Step 2 is mole to mole ratio. Okay, so we're going to take phosphorus and we're going to take the moles of, oxygen is, phosphorus is low. So the moles of phosphorus is 4. That's the lower mole. So you're going to take the moles, so first let's look at phosphorus is 1.4076 divide by 1.4076. So that equals to 1. Okay, 1.000, just to be more exact. All right. Next is for oxygen. Oxygen is 3.525 divided by 1.4076, and that is going to give you 3.525 moles. So basically these are still moles. Okay, so that's the moles of phosphorus, that's the moles of oxygen. So fine, you can write the empirical formula, but the problem is because it's a decimal, so we need to change it. Okay, so this is coming out to be, this is 2.5. This is 2.5, and that's 1.00. That's 2.5, my mistake here. This is 2.5, 2.5, and that is 1.0 moles of phosphorus. This is right. Okay, so with that said, we are going to now take it as, we have to now make it this 2.5 into 2.5 oxygen, phosphorus 1.0, and oxygen is 2.5. So we need to change it to the whole numbers. So the only way that's going to happen is if you take this whole thing and times 2. So that means phosphorus becomes 2 and oxygen becomes 5. So we need to get that whole number. And in order to do that, we have to change here. 2.5 needs to be multiplied in order to get the whole number, the simplest whole number ratio. So this is the empirical formula of P2O5. Okay, so I hope you found it easy, and thank you for watching. Bye-bye.